Students, this is question number 8. Geometric progression as first term as a common ratio as r and sum to infinity as s. Now you have a second geometric progression as first term a common ratio as capital R and sum to infinity as 2 times s. First question, show that r is equal to 2 times r negative 1, and for the second part B, given that the third term of the first GP is equal to the second term of the second GP, and what are we to do? We have to express S in terms of A. That's for the second part. Okay, so let's do the first part, solution. Now the sum to infinity of the first GP is given by a formula S is equal to A over 1 minus R. So A is the first term and R is the common ratio. Okay, now for the second GP we got the sum to infinity is 2 times s is equal to A over the common ratio is R. Okay, so this is what we have got. Now what I'm going to do, I'm going to take this s and I'm going to substitute it here. So this means 2 times of A over 1 negative R is equal to A over 1 negative R. Now A gets cancelled. I cross multiply. So it's going to be 2 times of 1 negative R is equal to 1 negative R. This means 2 negative 2 times R is equal to 1 negative R. I move everything to the other side. R to this side. So R is equal to 1 negative 2 positive 2 times R. So this will give me 2 times R negative 1 is equal to R, which is required. Right. Why do I say it's required? Because this is exactly what is needed. Okay, let me do the second part. Given that the third term, now the third term of the first GP, this will be of the form. Now we know it has got a ratio, right? Common ratio is R and the first term is A. So the third term will be of the form A times R squared. Now we also given that the second term of the second GP, that is going to be A times R. Now these two are equal. So also given A times R squared is equal to A times R. Right. So A gets cancelled. I'm using this. This means R squared is equal to capital R. But my R is this, so I substitute here. So 2 times R minus 1, the whole squared is equal to R. I expand this. I get 2 squared R squared negative 4 times R positive 1 is equal to R, which means 4 times R squared. If I bring it here, I get negative 5R positive 1 is equal to 0. So I have to solve this. So let me solve this. So what do I have? We have 4 times r squared, negative 5 times r. What is it? It's positive 1 here. Positive 1 is equal to 0. So I'm using the quadratic formula, negative b plus or minus root of b squared, negative 4ac divided by 2 times a, which is negative of negative 5 plus or minus negative 5 squared, negative 4 times a, c is 1, divided by 2 times of 4, this is 5 plus or minus root of 25, negative 16 divided by 8, 5 plus or minus root of 9 divided by 8. This is going to be 5 positive 3 divided by 8, which means 8 over 8 is equal to 1. So my r is equal to 1, or 5 minus 3 divided by 8, which is 2 over 8, which is 1 over 4. So r is equal to 1 or r is equal to 4. Now we have to find the common ratio. Now since r is equal to 2 times r minus 1, 2 times r minus 1, I substitute 1 and I get 1. Now this is a contradiction. Why? Because r cannot be equal to 1. R should be less than 1. That's a common ratio principle. Right, so we drop r is equal to 1 and take r is equal to 1 over 4. Okay, so that means s is equal to a over 1 negative r. Now from here, this means r is equal to 2 times of r minus 1, 2 times of 1 over 4 minus 1, which is 1 over 2 minus 1, which is negative 1 over 2. So this is the value of r. This is acceptable. So you substitute the a over 1 negative of negative 1 over 2, which will give you a divided by 1 positive 1 over 2, which is a over 3 over 2, which is going to be s is equal to 2a over 3. So this is a perfectly acceptable answer. So we move on to the next one.